some considerations on the automatic vulnerability scanning. So as I said already multiple times, web applications are quite a mess right now. So their functionality is not thought through really thoroughly by the developers and architects and designers. So interacting with them in an automated manner is much more risky than doing that on the lower layers of infrastructure, where automatic vulnerability scanning is a thing for at least 20 years now. Okay, so web applications are different. They are more fragile, and their business logic is more complicated, and they didn't have this long period of time to withstand all the threats out there. Yeah, so the evolution window was not so wide for them, and this causes a lot of trouble. So it's possible to break a system or an application by a vulnerability scanner below the web application level. Yeah, and it's much more probable to do that or to cause some trouble by scanning automatically on the application level, on the web application level. So just a few examples. Okay, I will give you one of them. So imagine a banking application that uses one-time passwords sent over SMS messages to the clients once they are trying to connect with legitimate credentials. Okay, so you are typing in your name, you are typing in your correct password, your valid password, you press button, login, and then you get another form with just one input control, yeah, and you have to type in the SMS that is sent to your mobile phone. So you have to do that within some period of time. And say you are testing this application and you are given a valid username. Yeah, so you have to do something more than just full black box testing. You have to review what legitimate users can do against the application, how they can abuse its functionality, whether they can have access to other users' data and functionality, and so on. Yeah, and you type in these credentials into a vulnerability scanner. Okay, and what it does, it just may possibly not identify the login or logout control, the link or a button on the web page as such, yeah, and just try to fill in the forms with this login and password every time they encounter a login window, and do it in circles, yeah, and repeat that many times. And in this way basically wipe out your clients subscription for SMS messages they get from their mobile carrier. Okay, so that's one logic flaw that should be identified, of course. Yeah, so this is like a security threat of a sort, and this should be reported, but it can be done apparently by less effect on clients' operations and budget. Okay, so it's okay just to show that it is possible to do that repeatedly without any limits or rate limits. Yeah, so we will talk about it later. There are different security considerations in this scenario, but doing that automatically, unattentedly, yeah, like not giving attention to what's going on in the background, is irresponsible from the penetration tester's point of view. So pointing fingers on who did what wrong is not a good idea in this situation. You should think about that beforehand. Okay, so of course there is a lot of things that has to be automated, because you cannot fuzz an application fully. Yeah, you cannot fuzz an application to the most extent possible manually. That's not possible. You have to write scripts, you have to use some means of automation, but doing that on the background, not paying attention to whether everything is going on okay, yeah, and whether the web server is available still, okay, it just responds with a normal behavior without any unacceptable timeouts in operation, that's not good. That's not good. You should avoid that. You should still be there, and in the base case scenario, you have to prepare your client for that activity and have someone on that end to just wait for an emergency to resolve. Okay, so let me give an example of an attack that happened. Not just happened, that happened for many times in the real life, in my career, and in my team, in my multiple teams before. So we call that breaking in before the lunch. Okay, so it's literally going in for an internal penetration test like at 10 a.m. and getting out before the lunch with a bunch of rows from a very critical database. Okay, so what happens? You just get into the LAN, and whether it's an external engagement and you already have some persistence in the LAN, or you just have this internal penetration test going on. So you find a web application that is presumably on Java, yeah, on some Java server pages extension or something. So you just assume that there is some Apache Tomcat on that behind that, and you go to its management console URL, and that URL shows you login password window. You type in Tomcat, yeah, and most vulnerability scanners will find that for you, most probably, and you get in. So you can deploy new applications, remove existing applications, or just turn them off. Yeah, so you can do all types of stuff. Yeah, and or just optionally, if the credentials are not default, but the Tomcat installation was not updated recently or for some period of time, you can find a vulnerability, yeah, that can allow you either get some remote code execution, or there are ways to upload JSP to the Tomcat server without actually logging in. Okay, there is a way to circumvent that authentication control. There are exploits for that, even in Metasploit, I guess. Okay, so yeah, you compromise it in some way or another, and then you have this ability to upload applications in so-called WAR format. So you just make that WAR file out of MSF Venom, for example. Yeah, you just create a interpreter for Linux in the JSP bytecode format, and you just upload it there. It's a kind of jar, but for deployment in Tomcat, you know. So yeah, you just run it. Then you just point your browser to the URL of this new JSP, and it runs and it connects back to your interpreter handler in the Metasploit, and you get remote access on the operating system level. Just run bash as a Tomcat operating system user. So from there, you can go to any application directory on Tomcat, yeah, and most of them will contain XML or text files that configure the connection to the database, yeah, and then you just use that username, password, and database name to connect to that Oracle or Postgres or whatever, and exfiltrate the data. Yeah, not all the data, of course. You just maybe it would suffice to make screenshots of some top 100 arrows from a certain database, and by redacting the very critical fields, you would be able to show that you were there, and this is totally ownable. Okay. Optionally, if you see that this is, for example, a dual home host, yeah, so it has multiple Ethernet connections to different segments on the network, especially if it's an external host, which is, yeah, I hope that happens rarely. However, that theoretically could be possible. So you maybe want to have some elevated permissions on that host for persistence and for pivoting further into other networks and maybe deploying some tools that require root access to the local operating system. So you could just deploy an SSH key, for example, for a Tomcat user, and use some local privilege escalation vulnerability to get root. So do all that traditional type of stuff we perform during post-exploitation. So yeah, this is quite a realistic example that was quite common a few years ago. I would say 5 or 6 years ago. That was something that was working. I would say in a couple of banks, so because banking applications are deployed in Java application servers all the time. So that would be quite a promising way to show the business value of an internal penetration testing exercise to your client.